Hi everyone, I hope everybody's being safe during this quarantine time. Today is lesson 3 of our fraction series, and we're going to be learning about greatest common factor, and we're going to be learning how to reduce fractions. But the first thing we have to do is learn about greatest common factor. So let's put that in our vocabulary section. Remember, if you're using the little notebook I told you that the little marble notebook, then you're going to put this in the back of your notebook because vocabulary goes in the back. So let me write the definition for greatest common factor on the board. The greatest common factor, a lot of times you will see this referred to as just GCF. So that is how sometimes you will see it, is GCF. But that means greatest common factor. So, greatest common factor, I've lost my thing, sorry, means just what it says. It is the greatest common factor, okay? So the GCF of two numbers. So on this, it's not very hard to remember what that is at all, is it? Because greatest common factor just means the greatest common factor between two numbers. That's all that means. So now we've got to learn how to find the greatest common factor. Okay? So when you do this, the first step is to list all the factors. And remember, do you remember what a factor is? Let's go. Let me make sure you understand what a factor is. A factor, if you have a multiplication problem, okay? A multiplication problem. Remember, the answer is the product. My product. Oh my goodness, I can't spell, sorry. Product. So the answer is the product, and the two numbers that are being multiplied are the factors. So these two numbers are the factors, and the answer is the product. So that's what we're talking about, is factors. The two numbers that are multiplied together to make the product is the factors. So when we're finding the greatest common factor, then we have to list all the factors. So let's look at two numbers, 12 and 15. Okay? Now, what we have to do is list the factors. Now, this is how I've always taught it, and usually it's how children learn the best. So we're going to look at 12, and we know that 1 and 12, 1 times 12 is 12. The next number is 2. Does 2 go into 12? Yes. So 2 times what? 6, right? Okay. So the next number would be 3. Does 3 go into 12? Yes. And 3 times 4. So those are the factors for 12. Okay? Now on 15, we know that 1 and 15 are factors. Now, 1 and the number will always be, because 1 will go into every number, right? Because 1 times the number is the number. So this is always going to be, even if it's a prime number, which means only 1 in the number will go into it, is a prime number. So you still have factors, it's just 1 in the number. So always put 1 and whatever number it is first, and leave you enough room Now, I left enough room here, but I know how many are here, so I didn't leave as much room. So let's go again. Will 2 go into 15? Remember, to know if 2 will go into a number, it has to be even. So this number is not even. So that means 2 will not go into it. Will 3 go into it? And I might do a lesson on the divisibility rules, because this helps with divisibility if you know your divisibility rules. So the divisibility rule for 3 is if you add these two numbers, 1 and 5, if you add them, you get 6. And 3 will go into 6, so you know 3 will. So 3 times what? 5. Okay? Will 4 go into it? Now, if you know your multiplication tables, you know that 4 times 4 is 16, so it won't go into 15. And then 5 is our next number. So those are the factors of 15. Now, we're looking for the common factors. You don't really have to do the 1 if you don't want to, because 1 is every one of them. So you don't have to do the 1. We know that 3 is in both, and that's it. So since that is the only common factor, that means the GCF of 12 and 15 is equal to 3. Okay, so let's try another one. Let's look at the numbers 24 and 30. Okay, so let's do the factors of these two numbers. So let's look at 24. We know that 1, I'm going to move way over, and 24 is a factor. Will 2 go into 24? Is 24 even? So yes, so 2 will go into it. So 2 times what is 24? And that's 12. Okay. Will 3 go into it? So remember, the divisibility rule for 3 is if you add these numbers, 4 plus 2 is 6. 3 will go into 6, so we know 3 will go into it. So 3 times what is 24? 3 times what is 24? And we know that that is 8. Will 4 go into it? Now, there's not really a divisibility rule for 4. You just kind of have to know your multiplication tables. But we know that 4 times 6, and I kind of ran out of room, but I know that's it, because 5 will not go into it. Remember, the divisibility rule for 5 is it has to end in either 5 or 0, so 5 won't go into it, and then the next number is 6. So I actually did pretty good. How about 30? 1 and 30. Will 2 go into it? It's an even number, so 2 will go into it. 2 times what? 15. Remember, when you're saying 2 times what on any number, you do half of it. So half of 30 is 15. So 2 times 15 is 30. Will 3 go into it? Remember what I said, you add the numbers, so 3 plus 0 is 3. 3 will go into 3, so 3 will go into 30. So 3 times 10, 4. Will 4 go into it? So 4 times what gives you 30? If you know your multiplication tables, you know you can't do that. The closest would be 4 times 8 is 32. 34, 5. Will 5 go into it? It ends in a 0, so 5 will go into it. 5 times 6. And that kind of gets us right where we need to be to end it. Now, like I said, now we do the common ones. You don't have to do the 1. So let's do 2, 3, 6, and that's it. That's all that'll go into it. So when you're doing the greatest common factor, you do the greatest one, which means it's going to be 6. So the GCF of 24 and 30 is 6. I had to look to make sure. So you think you can get that? Now, the reason we needed to learn greatest common factor is so that we can reduce fractions, okay? Because whenever you add, subtract, multiply, or divide fractions, whatever you do, you always have to reduce your answer. Most teachers, when you do those problems, if you don't reduce your fractions, your answer's wrong. So you have to learn how to reduce fractions. Now, the GCF is how we do that. We have to find the greatest common factor of the two denominators to reduce. So let me see. Let me erase this because we're going to put another vocabulary. So we're going to put reducing fractions in your vocabulary. And this means to change a fraction to an equivalent. Oh Lord, I hate having to spell words. Okay. To change a fraction to an equivalent fraction that there is no number except the number 1 that can be divided evenly into both the numerator and the denominator. That's a long definition. So if you need to pause the video and write this, do that now. Pause the video and write this into your vocabulary. Okay, so we do this by dividing the numerator and both the denominator by the GCF, the greatest common factor. So that's why we had to learn that first. So let's do a few of the reducing fractions. Okay, so let's take the fraction 10 over 30. So what you're going to look at is what is the greatest common factor of 10 and 30. Now, you can do that by listing them out, and that's what you might have to do, but this one has a shortcut. The reason I wanted to do this one first is so I could show you the shortcut. Whenever you have a fraction that has a 0 on top and bottom at the end of the number, only at the end, you can cross that out, and the reduced fraction is what's left, which is 1/3. So that one was easy, okay? But some of them are not going to be that easy. But I wanted to show you that shortcut. So whenever you have a fraction that has a 0 top and bottom at the end of the numbers, it has to be at the end of both numbers, you can cross those zeros out, and what's left is your reduced fraction. So that's just a little bit of a shortcut on that one. So let's try, let me see, I'm trying to remember. Okay, let's try 12 over 30. Okay? Now, let's look at 12, and we did this one, so 1 and 12, 2 and 6, 3 and 4. And the other number is 30. We also did this one, 1 and 30, 2 and 15, 3 and 10, 4 won't go into it, and then 5 and 6. And when we looked at the common, we got these and this, and we know the greatest common factor is 6. Now, after you find the greatest common factor, you come back to your fraction and you divide both the top and the bottom by your GCF, and that leaves us with 2 over 5. So 12 over 30 reduced is 2 over 5, because nothing else will go into 2 or 5, so except for 1. So that is a reduced fraction. Okay? Now, hopefully, with practice, you won't have to write your GCFs out. You can do those on your own. So let's try another one. I was going straight to problems, so let me go over here. Okay, how about 3 over 12? Okay, now, kind of a little shortcut, okay? If one of the numbers is a prime number, remember a prime number means nothing will go into it except 1 in itself. That's what a prime number is. So if one of the numbers is a prime number, which 3 is a prime number, instead of doing the GCFs, what you do is you say 3, how many times will 3 go into 12? Because we're going to divide both by 3, because 3 is a prime number. So we know that 3 divided by 3 is 1, 12 divided by 3 is 4. Okay, so we didn't have to really list the GCFs. This one was prime, we wouldn't have had to do that anyway. But if we had done this, we would have seen that the GCF is 3. Okay? Let's see. Let's do another one. I'll make sure I've written some down. Okay, let's try 24 over 54. Now, even though the top and the bottom numbers are 4, you can't cross those out, just to make sure you understand. You can only do that with the zeros, okay? So let's do the GCF of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And then the GCF of 54, I'm going to have to think about this one, sorry. 1 and 54, it's even, so 2 will go into it. 27. 3, we're going to add these numbers together. 5 plus 4 is 9. 3 will go into 9, so it's going to be 3, 118, I think. Now 4, will 4 go into it? No, I don't think so. 5 won't go into it because it doesn't end in 0 or 5. 6. Will 6 go into it? Yeah. Times 9. Now I think that's it. I'm trying to decide if 4 goes into it. 4, no, 4 won't go into it. Okay, so our common factors are 2, 3, 6, and that's it. So our greatest common factor is 6. Okay, after we find our greatest common factor, we go back up to our problem and we divide by 6. So this is going to be a 4 and this is going to be a 9. So our greatest common factor, our reduced fraction is 4 over 9. Okay? Okay, let's try a few and see if you can do them. And that's what I had written down. Okay, so number 1 is going to be, lost my place, 18 over 48. Number 2 will be 4 over 6. Number 3, 27 over 36. And number 4 will be 24 over 36. So when you find your greatest common factor for the factors of 36 here, keep it for this one. You don't have to do it again. You only have to do it one time. And I have a number 5. Number 5 is 9 over 54. Okay, so do those 5 problems. See if you can do them. Remember, list your factors, find the common factors, find the greatest common factor. Then come back to your problem and divide by that GCF. Now, if you can do it in your head without doing all that, that's fine. Just make sure you have it at lowest terms. Nothing else will go into it but a 1 and the number. Okay? So pause the video and do these problems. Okay, so let's see if you got the answers right. So what will go into both 18 and 48? And I think it's going to be 6. Oh, 6. So 18 divided by 6 is 3. 48 divided by 6 is 8. Now, I didn't say this before, but let's look at our reduced fraction and make sure nothing else will go into it. And on this one, nothing else will go into it, so this is a reduced fraction. But if something else will go into it, it's not that you got it wrong, you just didn't find the greatest common factor. So if for some reason something else will go into it, don't erase and start over. Just then do this problem as if it was this problem and go ahead and divide again. That's fine, as long as you get down to your greatest common factor, okay? Okay, on this one it's pretty easy. They're both even, so we're going to divide by 2. And so our reduced fraction is 2/3. On this one, the greatest common factor is going to be 9. So when we divide, we get 3 over 4. On this one, now this one you might have not gone far enough, because if you didn't do your greatest common factor, if you were trying to do it in your head, sometimes this one would be one of those, because our greatest common factor is actually 12. But if you were doing it in your head, you might have said 6. Okay, so our answer is 2 over 3, 2/3. Now, let me show you if you didn't go far enough. Our problem is 24 over 36. If you were doing it in your head and you said, oh, 6 will go into both of that, so you divide it by 6, and you got 4 over 8. Sorry. Okay? Now, don't erase if you see that something else will go into it. Don't erase it. It's fine. Now, you know these are even. Go ahead and again divide, and you would get your 2/3. Wait a minute. I messed up. Oh, this should have been a 6. Sorry. This should have been a 6. Yes. Because 36 divided by 6 is 6, not 8. I don't know what I was doing. So then you divide by 2, and you get your 2/3. So we still came up with the same answer. So when you do this and you see you didn't go far enough, don't erase it. Just go ahead and divide again, and you will get your lowest common terms. Okay, number 5. If you look, 9, it's not a prime number, but it is the greatest common factor. So we know that we're going to divide by 9. And we're going to get 1 over 6, right? Yeah, 1 over 6. So did you get those right? And like I said, even if you did this, you can go on and divide. So that would not have been wrong. You just needed to finish it. Okay? Now, that's all I have for lesson 3. But remember, you can go to the blog, which is studieswithmisscolette.wordpress.com. Let me write that down real quick. I hadn't thought about writing it down. And everything's small. studieswithmisscolette.wordpress.com. Okay? Now you can go to the blog and you can message me with questions, and I'll either try to answer them there, or I'll try to get with you and FaceTime so that I can do it on the board and you can ask me questions. And I am willing to do that at any time. And also remember to please subscribe to this channel. Like the video, please. There's something about liking the videos that helps on YouTube. I don't know what that is. And in lesson 4, I think I am going to put in divisibility rules to make sure, because if we're doing this constantly, reducing fractions, if you know your divisibility rules, it will help a lot. So I think lesson 4, I'll do divisibility rules. So I'll see you in lesson 4. Bye.